This will be an attempt to do Tetrahedraverse intro. Isn't that cute? This is my cosmology. This is the thing I came up with that explains the universe. I've been on it for 25 years. It's been up on my website for 18. I just want to do everything I can so that somebody else somewhere out there will pick it up, hopefully pick it up, study it, learn it, and it won't get forgotten. Because if I die before somebody else picks this up, it'll go away too. And if it really is the answer, not saying that it is, but if it really is the answer to what the universe is, and I die and it gets lost, that would be a great crime. Tetrahedraverse. Intro. The universe is a spherically compressed set of dimensionless, non-coalescible points. Let's examine the phrase. The universe is a spherically compressed set, large number, of dimensionless, we can argue about that later, non-coalescible, that's very important, points. Teeny little guys. The universe is a spherically compressed set of dimensionless, non-coalescible points. Non-coalescible is important because non-coalescible means the points that it's composed of cannot be pushed together to become one. They resist. How do they do this? I say they repulse. They have a property of repulsion toward each other. It's the only property other than existence that they have. And they're dimensionless. Being spherically compressed all together and repulsing should generate a geometry. And lo and behold, it does generate a geometry. It boils down to what can be modeled as a ball packing. The geometry is nominally a network of vertex order 12. Kepler said, and Hales and Ferguson recently said, that the tightest possible packing for equal radius balls is a cubic close packing or an hexagonal close packing. Either one. They're both equally tight. They can't pack that way in a sphere. In other words, Hales and Ferguson are right for an infinite number of points, but they can't pack that way inside a spherical container. A cubic close packing requires an orthogonal packing force. There has to be a packing force. In tetrahedraverse, the packing force is the spherical compression. And the packing is generally a network of vertex order 12-ish. It's more like a random jammed, what's called a random jammed packing. Anyway, I want to note that later when you see one of these things up on the hillside in stainless steel, this is misleading. It's a model. All models are misleading. The points are free. They're loose. The only arrangement that they have is that which results from them repelling each other. And they end up repelling each other to the tune of 12 around 1 in general. 12 around 1 makes an icosahedron. This is an icosahedron knot, because it's not quite. It's not regular. These little guys are gaps, and that's important. We'll deal with gaps in the second video. These videos, this series of videos is going to be unedited, no gimmicks, no tricks. I just have this idea that I think explains particle physics, and I want it out there, and I want some followers and some students and some people who will not let it disappear when I die. Thank you very much. Later.